Prove and explain graphically the difference between the relations. So in that, first one is x of n delta n minus n0 equal to x of n0, and second problem is x of n dot delta n minus n0 is equal to x of n minus n0. So we solve first. Now what is given? X of n into n minus n0 is equal to x of n0. So here x of n is the input sequence. So input sequence can be given by, so here we can write here x of n is input sequence and it is given by, and let input sequence is given by, we consider one value, that is it is 1 1 2 1 1. So we draw the diagram for this. So it is n, and this one is x of n, that is equal to 1 1 2 1 1. So for this is x of, this arrow denotes x of 0. So for x of 0 value is 2. So it is 2. For x of 1 it is 1. It is 1. And for x of 2 it is also 1. Now for x of minus 1 it is 1. And for x of minus 2 it is 1. So this is the sequence x of n. This figure shows sequence x of n. Now next part is, we know that delta n means unit impulse. So we write the equation for this. Now we write here, we know that delta n is unit impulse. So it is defined by delta of n is equal to 1 when for n is equal to 0, and it is 0 otherwise, that is for any other values, or we can write here elsewhere. So now we'll draw the sequence for this delta n. This is n, this is delta n is equal to 1. It has one value for n is equal to 0, and for all other values it is 0. So this figure shows unit impulse delta of n. So here we draw xn delta. Now we have to draw the delta n minus n0. So delta n minus n0 means what? It means there is a delay of delta n by no points. So we will represent this equation also. Now delta minus delta 0, minus means it is delayed, or delta minus delta 0 indicates delay of delta of n by no units. New units, as they doesn't give any value like 2, 3, 4. So sequence delta of n minus n0 can be represented as delta of n minus n0 its value 1 for n is equal to n0, and it is 0 for n not equal to, that is for all other values. So for example, we consider here n0 as a 1. So for example, say n0 is equal to 1, so equation will be delta of n minus 1 is equal to 1 for n is equal to 1, and it is 0 for n not equal to n0. Now we will draw sequence for delta of n minus 1. So we draw here, this is n, this is delta n minus 1, it has values 0 and so for 0 it is here, and next is for it's here. So this is the sequence for delta of n minus 1. Now the next part is we have to make the multiplication of xn and delta n minus n0. Now multiplication of xn and delta n minus n0, that means delta of n minus 1. Can be drawn as xn. xn is, this one is n, this is x of n, 1 1 2 1 1, so this is 2 for 0, this one is 1, this is for minus 1, this is x of n. Next part is, and it is multiplied by, or multiplication by delta of n minus 1. So we multiply these two diagrams and the output is, this is n, this one is xn dot delta of n minus 1. So here 0 multiplied by 2, so it is 0. 1 multiplied by 1 is 1. 2 multiplied by 1 is so Here we are getting the resultant sample. And we assume here n0 is equal to 1. So result of multiplication is the sample at n is equal to 1. So this value is 1. So value is 1, and which is the value of x of 1, which is the value of x of 1. So x of n into delta n minus 1 is equal to x of 1, or we can say x of n into delta n minus n0 is equal to x of n0. Now the second part, x of n into delta n minus n0 is equal to x of n minus n0. So here this symbol indicates convolution. So we have to calculate the xn and delta of n minus 0. So therefore calculate x of n and delta n minus n0. Now we have the definition of convolution. So according to definition of convolution, y of n is equal to xn convolution of h of n, and the equation for this is summation k tends from infinity to minus infinity to infinity x of k into h of n minus k. This is equation 1. So consider here, let h of n is equal to delta of n minus n0. This is equation 2. So we assume two sequences. Now assume two sequences, that is xn is equal to 1 1 1 and hn is equal to delta of n minus n0, that is 0 and 1. Also assume value of n0 is equal to 1. Now step 1. Now what is step 1? Sequence x of k and h of k can be written directly, by directly replacing n by k. So x of k is and h of k is equal to delta of k minus k0 n0. So it is 0 and 1. So two different samples xk and hk can be written as. So different samples x of k and h of k can be written as x of minus 1 is equal to 1. Similarly, h of 0 is equal to 0, x of 0 is equal to 1, and x of 1 is equal to 1, and here h of 1 is equal to 1. Now plot x of k and h of k. So this is k, it is x of k is equal to 1, so for all values it is now step 2. Now what is step 2? Now the range of n is calculated. We have to find range of n, and lower value of n is equal to y1, therefore x1 plus h xl plus h is equal to minus 1 plus 0 is equal to minus 1, and higher value n tends to y0, xh plus hh is equal to 1 plus 1, it is 2. So range of n from minus 1 to 2. So we have to calculate. So calculate sequence y of n from y of minus 1 to y of 2. Range of k is same as that of the x of k. So this is sequence of h of k. So range of k is same as x of k, and k varies from minus 1 to plus 1. Now next is step 3. We put values of k in equation 1. So yn is equal to summation k changes from minus 1 to plus 1 x of k into h of n minus k. This is equation 3. So to calculate yn, put the values of n. Now we have to calculate y of n, put values of n from -1 to +2. Now we have to calculate this is a calculation of y of -n. So equation for this is y of -n is equal to k changes from -1 to +1 x of k into h of -1 minus k. This is equation 4. Now here h of -1 minus k is same or it is similar as h of -1 k minus 1 dot h of minus k, and it is folded version of h of k and h of minus k minus 1 indicates advance of h of minus k by one sample. So sequence for this is now this is advancing. So we can draw it. This is k, this is h of minus k minus 1. This is the sequence h of minus k minus 1. Now the next part is multiplication. Multiplication of x of k and h of minus k minus 1. So we directly add, and here y of minus 1 is obtained by adding all terms. So y of minus 1 is equal to 0. So multiplication of this and the output for this is k, this is x of k into h of minus k minus 1. So y of n is equal to, so this is 0 0, this one is minus 1, this one is minus 2 0 0. So this is the product of x of k and h of minus k minus 1. Now the next part is calculation of y0. So put n is equal to 0 in equation 3. So the equation will be y of 0 is equal to summation k changes from -1 to 1 x of k into h of minus k. Now here the sequence for the h of minus k, the sequence for x of k. So this is x of k 0 1 1, so this is 1, this one is also 1, for this it has value 1, and for this one it is 0. Now multiplication of this with h of minus k. So it has values 0 1 0 0 1 0 0. So for 0 it is 0, for minus 1 it is 1, here it is 0, and here also 1. Now we have to multiply it and we get the answer as x of k into h of minus k is equal to 0 1 0 0. This is 0 1. This is the product of x of k into h of minus k. Now next part is calculation of y2. Now put y equal to 2 in equation 3. So it will be y of 2 is equal to summation k equal to minus 1 to 1 x of k into h of 2 minus k. Now we draw the sequence for xk and h of minus k plus 1. So it is this is calculation of y of 1, not y of 2. This is y of 1. So we put y is equal to 1 in equation 3, and the equation 3 is h into 1 minus k. This is equation. So here h of 1 minus k is same as minus k, h of minus k plus 1, and it shows delay of h of minus k by one sample. This is 1, so by one sample. So we'll draw the sequence for these two. So first we draw h of minus k. So it is k, h of minus k is equal to 1 0. So for 0 it is, and for here it is 1. So now we have to show the delaying, that is it is delaying. So it is h of minus k plus when it is 0 and 1. So it is 1 and this one is 0. So this is the sequence for h of minus k plus 1. So y of 1 is equal to it is 1. Now next is calculation of y of 2. So for that put n is equal to 2 in equation 3. So y of 2 is equal to summation k is equal to minus 1 to 1 x of k dot h of 2 minus k. We have to draw for x of, for this equation, that is for x of k and h of 1 minus k. So for this the output equation, the sequence is, this sequence is for the previous and this one is for y of 1. This this is wrong. So it is x of k into h of minus k plus 1. It is 0 1 0. Here I have drawn directly the output. It is not here, it is here. This is the sequence for x of k and h of minus k plus 1 product. So next part is calculation of y of 2. So we get put y of put n is equal to 2 in equation 3. So equation will be y of 2 is equal to summation k changes from minus 1 to plus 1 x of k h of 2 minus k. Now here h of 2 minus k is same as h of minus k plus 2. Similar process, and it indicate or it shows delay of h of minus k by how many samples? By 2 samples. So it is obtained by shifting h of minus k towards right by 2 samples. We will draw for h of minus k. So what is h of minus k? It is k. H of minus k, it is 1 0. This is 0 and this one is the 1. Now we delay it. It is delaying. How much? It is delaying by 2 samples. So h of minus k plus 2. As it is plus 2, it is shifted towards the right. One is 1 and this is minus 1. So this is the sequence h of minus k plus 2. Now we have to multiply both these. So x of k is, it is 1 1 1. So it is 1 1 and it is 1. This one is k. It is multiplied by h of minus k plus 2, that is 0 0 1. This 0, this is 0 0 and here it is 1. So output of these two multiplication is, it is x of k into h of minus k plus 2. It is 1 into 0 0 0 and 1. So it is 0 0 and it is 1. So y of 0 is equal to 1. So this diagram shows the product of x of k and h of minus k plus 2. Now we get the values of everything, that is y of 0 1. So output sequence yn is, y of n is equal to y of minus 1, y of 0, y of 1 and y of 2. So it is 0. Now we have to plot it, so it can be plotted as it is n, it is y of n, it is 0 1, this is minus 1 0 1 2. So for y 0 it is 1, it is also 1, and it is also 1, and it is 0. This is the output y of n. Now output sequence can also be written as, so now output sequence yn can also be written as y of n is equal to 1 1 1. Now from the previous graph it shows that the output yn is obtained by delaying x of k by one sample. So this can be obtained from the previous graph, that is the starting of this problem. So y of n is equal to x of k minus 1, but what is x of k? Xk is same as xn, so yn is equal to x of n minus 1, and yn is equal to, now here we assume n0 is equal to 1, that is initial condition. Initially we assume n0 is equal to 1, so x of n minus n0, so yn is equal to x of n convolution, so it is proved, hence it is proved. Thank you.